Safety Council meetings, the secretary is to chair and all CMD is to be present.
Yeah.
Mr. Dhanush.
Member of the OASD, na, sir.
Ah?
DG is the member of the OASD committee.
Yeah, DG is a member of the Safety Council member. Is a respectable member. Yeah. Yeah. Nice meeting you. Nice.
Nice to see you, sir, after a long time.
Long time, yeah, long time. I haven't met Dhanshuk Chauhanji. Mr. Dhanshuk Chauhan.
Yes, I am Chaudhary, not Chauhan. Dhanshuk Chaudhary.
Sorry.
Okay, no problem. Sir, good evening. I am DC Chaudhary, retired director, Industrial Safety and Health, Gujarat State.
Okay. Thank you. I am Datta. I am.
Yes, sir, I know you, sir.
Ex-Indian Oil, ex-YSD, and then advisor Naira.
Okay, good.
Rakesh Duveji is the person who has brought all of us together on the common platform.
Yeah.
Yes.
Thank you, sir. Thank you for.
It's a pleasure.
Yeah.
And we are supposed to have one professor from JNU.
Now?
Yeah, Mr. Professor P.K. Joshi. He's on the chat.
Hello.
Professor Joshi ji, good evening. Where are you?
Ji, good evening. Good evening to all of you.
Am I audible?
Good evening, Professor Joshi.
Yeah, good evening. Indeed, it is a pleasure to moderate this session with such
Am I audible, sir?
speakers.
Yeah, I will be presenting. Professor Joshi, I will be presenting a slide, maybe 15-20 minutes.
Yes, please.
So whenever they say start signal, we'll go ahead.
I hope you have checked your slide that you are able to exhibit it.
We are online.
I think, yeah.
Okay. So shall we move further?
Is it okay?
Yes.
Yes.
Good evening to all.
Okay, no?
Welcome to day 6 and the conclusion session of Raksha 2020, which is a 6-day webinar on disaster risk reduction by perception, talent, and the way ahead. Before going further, I would like to brief little bit about the event for our new joiners.
Please go ahead, Narendra ji.
Jain sir, myself Randeep Jaggi, Civil Defense Bhopal.
Hi, I'm sorry, there is some technical restart. Am I audible to everybody now?
You are audible, Narendra ji.
Okay. So hi, this is Ramchandran, and I would like to start the event. So good evening to all. Welcome to the day 6 and the conclusion session of Raksha 2020. 6 days webinar series on disaster risk reduction, perception, challenge, and
There is echo in the voice. I'll request you mute everybody and then you.
Okay. Am I clear now?
You are audible here, but you mute everybody and then start. There is echo in the voice.
I hope I am clear now. Before going further, I would like to give a little brief about the event to our new joinees. United Nations General Assembly has designated 13th October as International Day for Disaster Risk Reduction, and the theme for this year's event is 2020 is Disaster Risk Governance. And we welcome you all to the series of webinar named Raksha. Raksha is a Hindi word, means defense. We may not manage disaster, but can have a strong defense over it. This is the first event of its kind in this domain, where the industry leaders and eminent personalities and academicians from eminent institutes are sharing their thoughts and trying to find a consensus across industry and culture over disaster risk reduction. Raksha 2020 is upshot by the joint effort of ERD DMP Academy in association with Fulcrum Group and CRO CropC, supported by HealthCrum, which is a healthcare corporate health and wellness platform. You can view this preview session at Healthcare at YouTube channel as well. Moving further, I would like to introduce this event and the dignitaries. Today we are having a conclusion session. of 6 days mega webinar event in the backdrop of International Day for Disaster Risk Reduction. And today we have Dr. R.K. Elangovan, Director General, DGFASLI, a Labor and Employment Ministry, Government of India, as a chair of the session. We also have two eminent personalities in our panelists. They are Professor P.K. Joshi and Dr. And Shri Hirak Datta. Mr. Hirak Datta is a former executive director of OISD. Sir was accorded with the Lifetime Excellence Award for the Process Safety Management in Indian Oil and Gas sector in 2019. And Professor P.K. Joshi is a chairperson of Disaster Management Center of JNU. We also welcome the dignitaries of the previous session and speakers and vendors of past 5 years. We are thankful to. We also have Mr. D.C. Chaudhary. We are thankful to him, and he served as a director of Gujarat government and present a director of ERDMP Academy. The event will be initiated and concluded with the panel discussion of key speakers, honorable guests, and Dr. Rakesh Dubey, who is the industry expert and CEO of ERDMP Academy, with 38 years of experience in environment and disaster management institute, Home Department, Government of MP. And as this is the conclusion of the this 6 days webinar, I would like to thank all the guests who have made this event highly successful, and I'll be more than happy to say that we have more than 600 people who had viewed this event through Google, through YouTube, through webinar session, and a lot of people had participated in the event with a lot of comments. So we are very thankful to all the participants and the dignitaries, speakers, and all the organizers for this event. And now I would like to hand over the baton to Professor Joshi to make this conclusion session the first conclusion session of Raksha 2020 remarkable, with the support of the speakers and our honorable guests. Professor Joshi, the baton is handed over to you. Please take it further.
Thank you very much, Mr. Ram Shankar Minaji. Many thanks for this wonderful opportunity. I welcome to all of you to the final conclusive day of the series of lectures ERDMP Academy, Health Karam and CropSea initiated to observe International Day for Disaster Risk Reduction since the 13th of October. We have had a wonderful series loaded with thoughts, practices, and knowledge, which is needed to blend industry and academics for better research and governance. Today, we wish to discuss occupational safety and health. It is a multidisciplinary field convened with the safety, health, and welfare of people at occupation, with the aim to foster a safe and healthy occupational environment. Today, we understand that International Labour Organization ILO since 1950s and World Health Organization WHO in 1950s and then in 1995 share common definition of the occupational health. But seems this all started with labor movement arose in response to workers' concerns in the wake of the Industrial Revolution. If we go back to history, probably in the United Kingdom, the Factory Acts, which was there in 1802 onwards, it basically arose out of concern about the poor health of children working in cotton mills. Then later in 1833, people talked about dedicated professional factory inspectorate, which was probably more concentrated to children and young persons. And in 1844, the focus moved to women workers. In between, the Royal Commission report of 1840 sparked the public outrage, resulting Mines Act 1842 and 1850 made it possible for inspectors to have a look around premises of these locations. Therein in between, a Dutch practitioner, Otto von Bismarck, he basically inaugurated the first social insurance registration somewhere in 1883, followed by that, the first workers' compensation law in 1884. And today, what we see, workplace hazards, it has actually become a very common word. And now we have construction, agriculture, service sector, mining, and oil and gas. Everywhere it is talked about. And people talk about healthcare and social assistance in common. So as a result, entire world and whole set of nations, you name it, United States, European Union, Russian Federation, or many national legislation and public organizations, they talk about this and professional roles and responsibilities of it. And there are ways to identify safety and health hazards and contemporary development. So as a result, what we see is April 20 as the World Day for Safety and Health at Work. It is recognized by the International Labour Organization, and it is being observed since 2003. So to enhance our knowledge about these all facts and figures better, and from a very Indian perspective of oil and gas industry and related things, we have very luminary speakers today. We have Dr. R.K. Elangovan. He is Director General, Factory Advice Service and Labor Institutes with Ministry of Labor and Employment, Government of India. He would share his thoughts on National Authority on Occupational Safety and Health. We are also joined by Shri Hirak Dutt. He is ex-ED of Oil Industry Safety Directorate, an expert of oil and gas, to discuss on interesting case study of national gas disaster. What I learned from their profiles, both of them are highly educated. Just to give you a glimpse of Dr. R.K. Elangovan, he is being mechanical engineer, followed by MSc in environmental sciences, and also MTech in machine design from IIT Madras, and PhD in industrial safety from Alagappa University, Tamil Nadu. So he is, well known for his academic contributions as well, apart from his other commitments, wherein he basically, guide and supervise academic research, and also sit on many of the doctorate committees for research in field of occupational safety and health. And he has contributed not only in country, we could also trace that he has contributed in University of Texas while looking at occupational safety and health modernization programs. And likewise, it's quite long profile, but it is very impressive that he has intense interest in knowing, sharing, and ensuring that occupational safety and health is taken care very seriously. And that is the reason, and he is holding such an important position today with Ministry of Labor and Employment. Likewise, our another speaker, Shri Hirak Dattaji, he is having 4 decades of rich and varied experience while working both in PSU and private sector, both related to oil and industry organizations. He has worked in different organizations, and he is, excusing his all experience while interacting with professionals at IIM Ahmedabad, while interacting with in their management development program on safety in project management. Likewise, he is also supervising and interacting with institutes like IIT and other oil and coal related institutes, including BPCL, GAIL, IOCL, and whatnot. And he has been recognized for his Lifetime Excellence Award for his contribution in the field of process safety management in Indian oil and gas sector. So having such an distilled, experienced, and knowledgeable speakers itself is a pleasure for our group to hear today. With this brief background, may I request Shri Hirak Dattaji to share his story with all of us. And I'm very confident, we all will be much more literate today with wonderful deliberations from both of the speakers. While the speakers present their things, I will request all the participants to please post their queries, questions in the chat box, and we'll make sure that those questions are addressed within the given time frame. So with this brief introduction and remarks, I hand it over to Shri Dattaji, and I equally look forward listening to you. Please, over to you.
Thank you. Thank you so much. I'm humbled by your introduction. What I will do is, first of all, it's a pleasure to be here talking on this international conference, 6-day-long webinar on disaster risk reduction, challenges and way forward. That's the title of the session. And I'm thankful that I have been invited to share my thoughts. I will take about 20 minutes. Let me check. Yeah, I will take not more than 20 minutes to make a brief presentation. The presentation looks like this. Prelude to disaster reduction, case study on a major catastrophic incidents, what went wrong in that incident, what are the lessons we learned. I would like to link the catastrophic incidents with the organizational culture. Culture of the organization is very, very important. So I'd like to link the various disasters or catastrophic incidents which have taken place in the industry. How does it has impact on the organizational culture? And then I will a little bit talk about high reliability organization, how high reliable organizations have managed to ensure smooth, safe, and reliable operation 24/7. Just 2 days back, we had an incident in the natural gas pipeline of ONGC in Gujarat. Luckily, there were no fatalities. But then, if you look back and if you see, there had been a number of incidents which have been taking place in every industry. We had a styrene gas leak, which is a catastrophic incident which took place. Then we have boiler incidents which have taken place in Tamil Nadu and various other places. Then we had a gas leak, oil gas leak, oil rig gas leak at northeast of India. So in nutshell, and you all know the world over, worldwide, various incidents and accidents have taken place. My concern is accidents are going on unabated. What are we doing? What's wrong in our approach? Although we have made a lot of progress, but today we want to make a little more. How can we reduce the risk? That's the topic. How can we reduce the risk? And when we talk about disaster reduction, it's a systematic approach to identify the risk, assess the risk, and what can we do to reduce the risks. I come from oil and gas sector, so I will talk a little bit about the oil and gas sector. It's a highly hazardous industry. We handle a very high temperature at 500 degrees centigrade, operate at 200 degrees centigrade. Refineries, petrochemicals, they operate at 200 bar pressure. We handle hydrogen and various toxic gases. So therefore, oil and gas industry is inherently very, very hazardous. Added to this is many of the oil and gas industry assets are old and aging. You must have heard about the Digboy refinery, AOD Digboy refinery, Assam Oil Division Digboy refinery. It is more than 100 years old. And for the information of the participant delegates and other dignitaries, that many of our pipeline, more than 30% of India's pipeline has outlived its design life of 25 years. And therefore, it's a great challenge for everybody who is working in industry as to how we can ensure smooth and reliable operation. We need to reduce the risk, and that should be the industry approach. And the least preferred approach is PPE. I'm not saying PPE is not important. PPE is important, but that's the most least preferred method. The important thing is, or the administrative control. Those are some of the least preferred method. Important thing, most preferred things are how through engineering controls we can reduce the risk, how we can isolate the risk, how we can substitute the risk, or how we can eliminate the risk. We cannot reduce the risk to zero. It's not possible to reduce the risk to zero. What we can do is to bring down the risk to the level practicable, and that way can we operate the industry without any incident, without much of disaster or catastrophic incidents. Now, for this, I propose a model, and I have been talking about this model. We cannot achieve excellence, or we cannot achieve reduce disasters or risk, or cannot achieve incident-free operation unless we follow this model. And if you look at this model, at the center is the design integrity. Any plant, any plant, refinery, petrochemicals, process plants, power plants, any plant, steel plants, any plants, the most important thing is the design. Until and unless the design of the plant is robust, we will not achieve excellence in our operation. And when I talk about the design integrity, I'm talking about start from the in the nascent state itself. Look at the general arrangement drawing. Look at the P&I diagram. Look at the process flow diagram. The various equipment which the various industries are procuring. Do they match the relevant standards? Do they follow the ASME, American Standard of Mechanical Engineering Standards? Do they follow the API standards? If the design is not robust, if the safety interlocks or process safety instrumentation has not been built in the design at the nascent stage itself, I'm afraid will not achieve reliable and smooth operation, will not achieve risk-free operation. And therefore, design integrity is very, very important. Not only design must be robust, we must also know or talk about operational integrity. Know how to operate the plant. Now, when you are operating the plant, we must know the nitty-gritties of operation. How do you start up a plant? How do you shut down a plant? And mind you, when we talk about the styrene gas, I'm not talking about the styrene incident, but CCPS, Chemicals Board of Safety, Center for Chemical Safety Board, they have said that more than 5 times accident takes place during startup than during normal operations. So startups are extremely critical. We must know how to start up a plant. We must also know how to shut down the plant. We must follow the standard operating procedure. Knowing operation is very, very important. Not only design must be robust, we must know how to operate a plant. If there is a trouble in the plant, how do we troubleshoot the plant? That's where the role of managers and engineers comes forward. That there will be problem in the plant, but if there is a problem in the plant, how do we troubleshoot it? Follow the standard operating procedure. The problem is in many of the companies, this SOP stands for standard optional procedure. Now, if you make SOP a standard optional procedure, I'm afraid you are inviting problem. Follow the standard operating procedure. The third part is important is maintenance integrity. You may have the best of the design. You may know how to operate the plant, but if you don't maintain the plant, if the organization philosophy is based on breakdown maintenance, I'm afraid we are inviting risk. We are inviting problem. Today, organization has moved from breakdown maintenance to preventive and predictive maintenance. The mega gas compressor, hydrogen gas compressors in refining and petrochemical, which consumes a power of more than 7.5 to 10 megawatt, huge machines. Their integrity is very, very important. How do you ensure that? Today we have online vibration monitoring, health monitoring system, probes, which continuously monitors the vibration of these machines. It measures the axial displacement, it measures the horizontal displacement, and through that through all these instruments we can improve the maintainability or maintenance or reliability of the equipment. So therefore, design is vital, knowing operation is vital, maintaining the equipment is very, very vital. Do I maintain the equipment properly? Do I hand over the equipment when it is due for its maintenance? If you don't hand over the equipment when it is due for its maintenance, you are denying an equipment, static equipment or any other equipment, a health checkup. Now, if you do that, we are inviting problem. So we have talked about the 3, and the 4th part, as you all know, is human reliability. After all, it is the people who moves the process and technology. How much do we focus on training and educating our human resources? The organization which focuses on educating the human resources, I'm not only talking about our own employees, but I am also talking about the contract workers. If we train them, if we educate them, then we will achieve excellence in all operations. Then we will be able to reduce the risk. Then we will be able to achieve less accidents in all operations. How do we motivate our human resources? It's not only giving them money. Are they part of decision-making process? Are they engaged? I cannot produce results. It is the team which has to produce the results. I will talk more about it as I go further. In this context, I will talk about incident which had taken place. So how do we reduce risk? I say stick to the fundamentals. Design, fabricate, and install all facilities and equipment in accordance with the applicable industry codes that I have said, ASME codes, APIs codes, or various Indian codes which are available. Operate facilities and equipment within the design tolerances. Many times we go beyond that safety envelope, we go beyond the design limits, go beyond the pressure and temperature for which the process is designed. And if you go much beyond the set pressure and set temperature, we are inviting problems. Many times we operate our plants when we know that the safeguard, the safety instrumentation, interlocked systems are bypassed. Now, if we do that, we're inviting problems. Therefore, we should never bypass the safeguards. Critical safety systems should never be bypassed. That's very, very important. Analyze if there are frequent process upsets. We cannot just tolerate the process upsets. Many times what happens is we pass on from one shift to another. Okay, in my shift, this has not happened. Let me pass it on to the next shift. I'm talking about in continuous process plan. Now, if you're doing that, we are inviting problem. It's like treating a patient who has fever with paracetamol. Paracetamol is not the answer for a patient with fever. We have to go deep into it as the root cause as to why he's suffering from the fever. And therefore, if there are frequent process upsets, friends and delegates, please go deep into it. Identify the root cause as to why there are frequent process upsets. That's very, very important. Analyze equipment failure to determine their cause. That's what I wanted to say. Treat failure statistics in an actuarial manner. Now, if you can do that, we will be able to reduce risk. And then not only be our life, a life of ours, and life of our family, when we are talking about well-being, life of our community will be very, very safe. We'll talk about a catastrophic failure in a high-pressure natural gas pipeline which happened in India. An incident of fire followed by explosion took place in an 18-inch dia pipeline designed to carry natural gas. The gas was being collected from an oil head, and from the oil head, the pipeline is to take the gas and supply to various consumers downstream at the power plants, the fertilizer plant. Natural gas, as you know, is a feed to the power plant, is a feedstock to the fertilizer plants. The incident resulted in a multiple fatalities and substantial loss of property. The fire took place in an early morning. And how did it took place? I will come to it later. The source of ignition, early morning, there was a tea shop nearby. And when the tea shop owner early in the morning at 5:30 started the stove, it produced a source of ignition. The natural gas, which was at that place, I will say how it has come, resulted in a fire, and it took more than 3 hours for the firefighters to extinguish the fire. The pipeline, which was carrying the natural gas pipeline, 18-inch diameter, is a cross-country pipeline which was passing below a canal. It was observed. I investigated the incident. I'm part of Ministry of Natural Gas when I was head of OSD. It was observed that there was water and condensate along with the natural gas. We test reported the gas. The test report of gas indicated presence of CO2, and there will be CO2 from the oil heads, little bit of CO2. The pipeline was operating at lower capacity. Mind it, when a pipeline operates at lower capacity, means lower velocity, and at lower velocity, the chances of there will be some sort of corrosion. Internal corrosion was noted in the pipeline. Some damage also was noted in the external coating of the pipeline. There were past incidents of leaked natural gas mine leak was pumped in the pipeline at 45 kg per centimeter square pressure, that is 45 bar atmospheric pressure, because it is a cross-country pipeline taking from the oil head and feeding to far distant places to feed the power plant, etc. There were past incidences of leak at 6 o'clock position of the pipeline. And every time leak happened in the 6 o'clock position of the pipeline, the maintenance philosophy of the operator was to clamp it. You know what does it mean clamping? Just to put a iron pipe around the place where it is leaking and clamp it. Just like that to hold the leak. One early morning, profuse natural gas leak took place from the same clamp position from where earlier 4 or 5 times or more than that, 6 or 7 times, the natural gas leaked, and every time it was clamped. It was an overcast morning, and therefore earlier 2 days there was rain and it was overcast, so natural gas did not escape. Lighting of the stove provided the source of ignition. Devastating fire followed by huge explosion took place, and as a result, as I have said, and as I have shown in the diagram also, we lost many lives. Many palm trees over large areas were burned, including loss of property. And importantly, there was number of days of shutdown of the natural gas line. As a result, power plant and the petrochemical plant, which used to take natural gas as feedstock, also lost its production. What went wrong? Let me first talk about, please recall the model. I have talked about 3-4 important things: design, operation, maintenance. Let's talk about the maintenance philosophies. Number of times leak took place in a high pressure pipeline. And then we are clamping the high pressure pipeline, which is at a 45 kg pressure. Is it a proper maintenance philosophy, proper maintenance practice, which is adopted? We should never clamp the 45 kg pipelines, which were earlier shown a leak of about 6 to 7 times. Can you clamp it? That's the question we must ask to ourselves. And the answer is obvious: we cannot clamp it. We have to replace the pipe and take appropriate action. Now, you know, in a cross-country pipeline, there are sectionalizing valves. What for sectionalizing valves are given? Because if there is a leak in certain section of the pipeline, a certain portion of the pipeline, you can, through the sectionalizing valve, isolate that portion of the pipeline. So, designer had provided remote operated sectionalizing valve to isolate the section of the pipeline where there was a leak. But sadly, the remote operated sectionalizing valve did not operate. Again, another maintenance problem. We don't maintain. We purchase things, but we don't maintain things. It's like an air conditioner. You can purchase the best of the air conditioner, but if you don't maintain, if you don't clean the air conditioner, the filter of the air conditioner, it will not give the desired efficiency. So therefore, designer has given remote operated valve, sectionalizing valve, to close in case there could be some leakages, to isolate that portion of this pipeline. But those valves did not operate through remotely. So therefore, the operator or the field operator had to go and manually close. So precious time was lost. And when there is a leak and an explosion, which resulted in a fish mouth opening of the pipeline, the 18-inch pipeline, you can imagine as to how much gas will escape from that leak. Operation philosophy. Proper pigs were not used for cleaning the pipeline. Normally, scrapper pigs should be used. When we looked into detail, we found that foam pigs were used instead of spacker pigs. One of the important things which everybody should do in a pipeline business or any business is whenever pigging must be carried out at regular intervals. Not only that, pig residue should be analyzed for metal content. Now, when you analyze the pig residue, you will come to know that yes, we have some sort of iron content, and that will tell us that internal corrosion is going on. Design content considerations. Now, this is very, very important point, significant point. Designer has stated in his design that this gas pipeline is not for handling the wet gas. The pipeline was designed for handling dry gas, and therefore designer has envisaged a dryer before the gas is put into the natural gas pipeline. Now, somehow the dryer was not installed, and that's a grave mistake. Have you done the MOC, management of change? Designer, because from the wellhead, there will be always some water, there will be some COT, which will lead to weak bicarbonic acid. And weak bicarbonic acid, low velocity, not improper rigging, will lead to corrosion at the lowest point, and exactly that happened. And then we have not put the dryer. If it is a dry gas, such thing will not take place. So I've mentioned corrosion took place because of weak bicarbonic acid, and as a result, the pipeline failed. Not only that, the intelligence speaking survey was also done, an IPS survey which was conducted 4 years prior to that indicated metal loss in the vicinity of the canal under which the pipeline was passing. But the IPS report, which suggested that we must dose corrosion inhibitor to mitigate the corrosion, that the very, very important recommendation of that was ignored. If you ignore the warning signals, my dear friends and delegates, we're inviting problems. So exactly that is what had happened. So what are the lessons learned? Quickly, I will go through it. I have talked about it. Scrapping pigging must be done at regular interval. Instrument peak survey must be carried out, not in this, with various other pipelines. In this case, IPS was already run. Corrosion coupon must be installed. And whenever we found that corrosion coupon is more than 1 MPI, we must add, or we must do a thorough checking and add corrosion inhibitor to ensure that no further internal corrosion takes place in the pipeline. Leak detection system should be provided. Over-dependence, none of this is happening in various industries. Please, friends and gentlemen, outsourcing will be there. But outsourcing does not mean the responsibility of owner is not there. We must be there to constantly monitor, supervise. Giving it to a third-party agency is not good enough. You can give it, we must give it, but then our supervision is also very, very important. Any change with respect to design parameter, and Professor Joshi is sitting over here, he knows much more about the design. Whenever you are violating, whenever you are not putting something which designer has said, please carry out MOC. Dehydration facility must be provided. Pipeline which are in service for more than 25 years should be assessed for residual life assessment, that must be done, etc., etc. Let me link with the organizational culture. Why do people make errors? Why such error happen in an organization? This is directly proportional to the organizational culture. It's related to the poor safety culture. Is it related to absence of safety leadership? Is it related to lack of reporting system? Many organizations have seen. Not only in my role as OISD, I have been heading refinery also. People don't want to report incidents. Now, if you don't want to report and put things under the carpet, we are not going to solve the problem. We have to put things out and address, take out things from under the carpet and address them. Have the courage to address them, and then only we can overcome the problem. High stress, lack of motivation, employee engagement. I will talk about employee engagement, lack of training and education. In many of the organizations, only spareables are sent for training. And if that is the motto, that is the philosophy of the organization, I'm afraid the organizations cannot be called a progressive organizations. If you send your spareables for training, you are doing a great injustice to the human resource of the organization. And that must, so such sort of organizational culture, and that is directly related with the leadership. Leadership commitment. Does leaders walk the talk? Many leaders say that if you face an unsafe situation, stop the work. No person wants an accident. But then when there is an unsafe situation, a first-line supervisor who is at the control room, control panel, who withdraws the feed from a hydrocracker, the leader then fires him as to, why did you do that? Couldn't you control this simple operation? This is not walk the talk. Are you a role model? Job of a leader is not only to ask, give me the results. Anybody can ask to give me this result, give me this throughput, give me this much amount of sales. You don't leader for that. Job of a leader is to provide resources, to give them directions, to have a vision. If a leader doesn't have this, if a leader doesn't have such a commitment, if a leader doesn't create a trust, a leader must operate from a philosophy of, I am okay, you are okay. When I say I am okay, you are okay, it means I have trust and confidence in myself, and I have trust and confidence in the people who are working with me. If I don't have trust and confidence in the people who are working with me, I'm a poor leader. I'm not building a team. I'm a superior human being. I cannot be a superior human being. I make results. I have to produce results through my team. So if I am not building trust, I'm failing to building a team. And therefore, I'm failing in my basic responsibility as a leader. I have always tried to do so, God willing, I will like to do it throughout my life. Develop safety management system, measure it. Things which are measured only give results. Many organizations have SMS, but they don't measure it. They don't implement the safety management system. The problem in our country is people are aware of process safety management, but we are poor implementers, poor executors. The brilliant ideas, the brilliant suggestions, and I am not going to cite examples in our practical life, in our industry life, in our other boundaries of life. Brilliant ideas have failed because of unwillingness to execute or because of poor execution. We don't share results. We don't celebrate success. As a leader, we need to pat the subordinates. We don't celebrate success. Measure performance. If you don't measure performance, you cannot achieve results. So therefore, not only you must have develop a safety management system, for that matter, any system. I'm not talking about to hell with the safety management system. Safety is integral part of operation and maintenance and design. So if you want to reduce risk, you have to focus on these three elements. Please understand this. Okay, let me move on. I've taken a lot of time. These are attributes of high reliable organization. High reliable organization accept a much higher level of false alarm. And that's the good part of HRO. Many organizations ignore the false alarms. If you ignore the alarms, you're inviting problem. So therefore, HRO gives a strong response to weak signals. They set threshold for intervening very low. If there is some problem, they will intervene. Doesn't seem right? Intervene, investigate, go deep root into as to why did it took place. It's not like give a paracetamol to a patient who is having fever. Go deeper into it. HRO accepts a much higher level of false alarms. Quickly, I will go. HRO do not ignore any failure. It is necessary to address any level of technical, human, etc. Reluctant to simplify. HRO do not explain away problems. Instead, they go deep into the problem, find out as to why did it happen, and reject the simplistic ideas. Simplistic ideas, simplistic diagnosis must be rejected until and unless backed up by a deep root cause analysis. Sensitivity to operations. If you believe that the man behind the machines knows the best, then the suggestions must come from the frontline officers. Hell, they are working in the site. They know. Please listen to them. We don't listen to them. We only give them instructions. And therefore, we are not building team. And therefore, we are not learning. Those first line supervisors, those persons who are operating the plant, those who are managing the panel, they know. Discuss with them. I can also learn from them. But we are managers. And therefore, we like to instruct. Resilience, flexibility in HRO means ability to, and that's the job of a leader. We must be able to anticipate troubles and improvise. The cricket match is going on T20. How many improvisations we have seen? De Villiers. 22 balls, 57 runs, total improvisation. Not in the textbook of cricket, but then that's the job of a leader. Expertise rather than authority. Authority means nothing. The mood thing is expertise. A person who has a subject knowledge. Process safety management, my dear friends, is a domain knowledge. Is a domain knowledge. It requires deep analysis. It requires operational experience. Until and unless you do that, we will not be able to achieve results. Way forward, last slide. Holistic approach in asset integrity management is a necessity. Shift focus from LTI, hell with the LTI. In my organization, for the last so many million hours, no accident took place. It gives me no solace. No solace. Yesterday's good performance cannot guarantee tomorrow will be safe. Do not ignore the warning signals plant speaks. Listen to the plant and listen to the people. Ensure safety critical items are not bypassed. As I have already mentioned, please operate within the design pressure and temperature. Offer equipment for maintenance and inspection whenever due. Do not ignore. A person also requires cardiogram when he comes to a proper age. Regular doctor checkup. Now, if you're not allowing your static equipment a regular inspection checkup, metallurgists are not looking into the equipment, you are denying an equipment checkup. You are denying a health checkup, and therefore it will fail. Conduct on-site and off-site mock drills, and that's very, very important. Develop emergency response plans. If there is a disaster, what I have said thus long, if we follow all these things, there should not be any incident. There should not be. If the design is robust, if we know how to operate, if my maintenance philosophy is strong, if the human beings are motivated, there should not be any accidents. But God forbid, if there is some incident, some sort of anything untoward, develop an emergency response plan. Focus on training and development. And I repeat again, organizations, please don't send spareables for training. Send the bright people for training. 10% of the superstars in the organizations or outstanding people in the organization, they are the motivators. They bring 80% of the average employees to the motivational level. Please understand this. This has to be understood by the leaders in the organization. Focus on training and development and create a safety culture. Leaders are not at the top. Leaders are there at every level. Each one of us are leaders. We have our circle of influence. And through that circle of influence, we must operate. Each one of us are leaders. We have our role. We have our responsibility. Please follow our roles and responsibilities. Through this, we will be able to reduce disasters. We will be able to have smooth, reliable, 24/7, safe, smooth operations. Well-being of people will be taken care of, and we will succeed in our mission. Any queries, you can ask or can write me to hirak1955@gmail.com. Thanks for this lovely opportunity.
Well, thank you. Thank you, Shri Dattaji. Though your each slide had multiple take-home messages, I would like to echo stick to fundamentals and integrity, design integrity. Many thanks for such an insightful and in fact a very passionate deliberation full of wonderful thoughts. Thank you very much.
Thank you. Thank you. I have taken a little more time. Sorry for that. But once I start, it gets a little bit.
Okay. So now let us, let me request Dr. R.K. Elangovan for sharing his exciting experiences and thought-provoking arguments. Over to you, sir, please.
Yeah, good evening.
Good evening.
Professor P.K. Joshi.
Yes, sir, you may start, please.
Yeah, I'll do it. First of all, I'd like to thank Dr. Rakesh Dubey, who has been very much following me to come for this session and to give some thought process. And I may not be making very detailed presentation. I'll just give some of the inputs. Probably, I know, being Sunday, sitting for a longer time and viewing the screen. Hope I am audible. Is there any problem in the audibility? Please let me know.
Sir, very clear, sir.
Okay, thank you. So my focus will be on how the chemical industrial disasters are managed. And basically, I will connect it to the safety related issues in a workplace and its connectivity to the disasters. And this is about my organization, DGFASLI, Directorate General Factory Advice Service and Labor Institute, which is the technical arm to assist the Ministry of Labor and Employment on policies and other framework on occupational safety and health. we are concentrating on two areas. One is your factories, second is docks, particularly in major ports. And we administer the Factories Act 1948 by coordinating with the state governments. We also enforce Dock Workers Act 1986 and Regulation 1990 in major ports. Our mandate is to work on occupational safety, health, and environment at workplaces. And these are our institutes, regional offices through which we render our services. Basically, we have a CLA at Mumbai, RLA at Chennai, Kanpur, Kolkata, Faridabad, and we are developing a new institute in Shillong. I thought this slide will be very important. If you look into the slide, almost 2% of the economic losses, financial losses, sorry, one second. Sorry, is contributed to the disasters, both industrial and natural disasters. And this clearly signifies how important for us to take care of the disasters. And this is the portrait of disasters that took place between 1980 to 2005. Our major focus will be on, this is a wrong data, it's a Bhopal gas tragedy that occurred in December 1984, the typographic error. And you can see the industrial world has not seen any such. Still, you find here and there accidents, multiple fatalities, financial losses, and so on. These are the disasters types, all of us know. My focus will be on the first two items, fire and explosion, and hazardous material list. These are the points probably I'll be speaking in this for another 15 minutes. When we talk about a workplace emergency, the difference between an accident and emergency in terms of the consequences. If the consequences are restricted, limited, if the damages are less, then we call them as an accident. And if the consequences, damages, effects of an accident is so huge, then we call them as disasters. By and large, disasters do involve public, huge financial loss and interrupt the production activity. And it also causes physical and environmental damage. And see, if you come to the industry perspective, the MSHA rules 1989 uses the terminology emergency. Your own, the Factories Act 1948, Section 41B4 talks about on-site emergency. Building and Other Construction Workers Act 1996 talks about emergency action plan. Particularly, emergency is by and large used in a technical context where an accident escalates into an emergency, where the situation becomes beyond the coping capacity of the system. And that particular word emergency can be equated to disaster. The only difference is the post-emergency scenario also is taken into account when it comes to disaster. And whether it's an emergency or a disaster, we need external assistance, which is very essential. In case of disasters, very important point is inadequacy. In case of emergency or disaster, there is a inadequacy of the facilities, infrastructure, technology, equipments, whatever it is. All those things, we have a limitation in the resources. And these limitations in the resources further complicate the situation. When you work in industry, you should have to look into two spectrums. One is normal working atmosphere, working environment. Whatever you do in terms of normal requirement, if you look the same requirement in terms of emergency, in terms of disaster, their volume will be very high, their numbers will be very high, the quantity will be very high. And definitely, when industries are finding it difficult even to match the regular operation level requirements, it will be much difficult for any industry to cope up and to prepare for the disaster level. That's the biggest challenge. And we know natural man-made disasters, and I'll be talking about industrial accidents. So when I talk about industrial disasters, it always relates to industrial accidents, and it is related to the hazards, potential of a substance or a system to cause injury or damage. And these hazards have to be identified in terms of Mr. Trevor Klitz. The hazards which could not be identified could not be rectified. So therefore, you need to identify, you need to analyze, and then you need to quantify, and you need to do a consequent analysis, and then you should come out to a conclusion how the hazard can be, restricted or minimized or prevented or prohibited from occurring. When we talk about disaster, it's the perception, in terms of risk. Risk is the perception of a human being with respect to the hazard. Let me say probability and consequence of occurrence of an hazard in reality, and how this risk of a particular facility, industry, or a storage system of a chemical factory or industry can escalate into an accident if so-called accidents are not controlled in its early stage itself. Very important point is the disaster preparedness. We come across so many cases. In one industry, you consider a chemical as flammable, even though the chemical is also toxic. And if you are not able to capture both flammability and the toxicity as a hazard, as an emergency, then definitely your preparedness will be in question. So the understanding of the chemical, understanding the properties and hazards is the primary requirement for the disaster preparedness. Identifying a chemical as a flammable and you forget it to be toxic, then it is going to be a major blunder when it comes to our disaster preparedness. And you can see the estimates, almost 28 to 40% of the small businesses never reopen following a disaster or emergency. Because the disaster or emergency is so huge, the factory cannot again start up. It can't start again because of the financial losses and business interruption, which is caused to an industry. The objectives, ultimately, you talk about safety or you talk about emergency or disaster, they talk about saving lives, rescuing the victims, minimizing the injury impact, financial losses, property losses, contain the incident, and also warn the community of the consequences, communicate to the relatives, safe rehabilitation, and communication to the government. These are the objectives in which we work. And you see, in an industry, there are two majority of them can be said as fire and explosion. And second group is toxic release. That the MS Structure was 1989 also is grouped into three type of assets, major assets: fire, explosion, toxicity. The fire and explosion, apart from the explosion having the over pressure or the blast pressure, the fire having the thermal radiation, most of the emergencies or the disasters do happen with the fire. And any industry, even go to the Factories Act 1948, we have a specific section, section 38 on fire safety. So maintaining a safe plant in terms of fire and having the escape routes, assembly point, everything, we need to focus on the fire evacuation plan, which is also a disaster control measure. And when it comes to fire, you need to do firefighting. When I talk about firefighting, The first thing is the fire extinguishing capacity, matching the fire load, appropriate fire extinguisher, properly trained employees, and then people are highly experienced in by conducting mock drills once in 2 months. And then you also try to have the laid out procedure and equipments and systems so that the firefighting is really meaningful and it's immediate. It doesn't allow time lag when it comes to reality. As I told you, when you talk about emergency or the disaster in industry, the role of PPE is very important. When we talk about PPE, it clearly indicates that we are unable to prevent a hazard, prevent a fire, prevent an explosion, prevent a toxic release. At least you protect yourself by having the PPE. So, in terms of toxic release, if you look in an industry, if suddenly there's going to be toxic release, and suppose you have 500 people, and we need to have 500 respiratory protection equipments, and if it is going to cross the boundary, the whole community need to be provided apart from evacuating them as per the requirements. But still, PPE plays a vital role, which is rather, I would say, an important element when it comes to disaster management in chemical industries. The fire exit route, again, this is an important issue. We have good maps, good plans, good layouts, good displays. But in reality, in case of a fire, whether the workers were trained enough to go as per the requirement, whether they have been properly informed, whether there had been proper knowledge sharing so that they perform the way the plan desires. Otherwise, whatever document you have, finally, the employee is not going to understand, or in terms of an emergency, if he is not going to react in the way which it was desired, then it's going to complicate the situation. The effects are going to be highly serious. And all your firefighting facilities, and my friend Mr. Iradatta also explained on this, the fire fighting facility, maintaining it, competency of the crew, and then knowledge level, training, location of detectors, all those things are also equally important. Talk about disaster management, because if a fire comes, the first and foremost thing is prevention of fire. The second thing is, if you cannot prevent the fire, at least the fire has to be isolated. The spread of the fire has to be stopped. And all these equipments, the facilities, fire protection system, prevention system, will help it to contain your fire door, your barriers for spread of fire, will help you to isolate it, and therefore the firefighting becomes highly effective. Assembly points, very important thing is, we always say you have to do a risk analysis modeling, you do a complete consequence modeling, and see, taking multiple wind directions into consideration, the assembly point which you are locating should not be within the risk contour, so that at any point of time, that assembly point will not be touched by the consequences of an emergency or a disaster in an industry. Many a times, it will be difficult to find out such a safe place within the factory premises. So the question comes, where to locate the assembly point? And we always find assembly points on an open area. And there are also thought process that should be under roof or a shade so that, the people are protected who are staying there. And adequacy of the assembly point, whether it can hold the complete number of people who work in a particular industry. See, the primary step when you come to a factory in a chemical industry, disaster prevention is we have to find out, because by and large in industry, they are related to chemicals. Again, the hazards of fire, explosion, toxic releases. And we have to see that the flammable, toxic and explosive chemicals are properly operated, stored, handled, manipulated, managed, processed, and stored in the way it desires. If you're not going to do these things in conformance with the controlled MLDS of the chemical, then you are exposing the chemical to various assets, and you are giving an opening for a hazard to occur and possibility of it resulting in an accident, thereby elevating to a level of an emergency. We need to focus on the operational experience. And in fact, again, I repeat this, again, Trevor Cliff's statement, you go to a bigger industry which has about 15 to 20 years of working experience, you'll find that all the accidents are repetitive. It clearly indicates that the hazards remain same, only the path of outcome may change, but the underlying hazard remains same. So the past history, past accident scenarios, our own experience and review process in terms of safety critical review or your own audit, your own risk analysis, all those things will be able to help you to understand how our systems are sufficient enough to take care of the disaster management. The MLDS is very important. In fact, I have seen when I carry out audit and we went to factories, we found, basic thing is MSDS. It talks about all the, at least bare minimum requirements. At least we should see that the bare minimum requirements which are specified in the MSDS should be complied with. And we should be in a position to apply multiple hazard identification tools, could be hazard, could be what if or HIRA, and see that the underlying causes for the accidents or disasters are unearthed and they are prevented at the source itself. And we should have a proper, dispersion modeling. It's very important. There are multiple softwares, from software, one software to other software, the damage zone, effect zone will change. But we need to use an authentic software which can help you to give the near to reality model. And that should be taken up as a consideration for doing our emergency or disaster preparedness and planning. If your modeling is improper, the planning will also become inadequate or inappropriate. All this, anything, the only one point here is that could be a flood or could be a storm, could be a lightning, could be a seismic activity or even terrorism can be an initiating event, including a technological emergencies for an emergency or an accident to occur. And once the accident could not be controlled or could not be controlled at source, could not be allowed to expand, then it escalates into an emergency. So we need to look in terms of disaster or emergency in terms of the natural causative factors also. And we should also look into domino cascading effect. We have seen a chemical released in one factory, making the people working in the other factory get asphyxiated, because the other factory may not even have use any chemical. So we also need to understand the domino cascading effects, the chemical reactivity between the different chemicals stored in a single area. And we need to look into the process hazards, runaway reactions, and then physical properties, temperature, parameter. Because whenever you take a chemical plant, we operate the plant within certain parameters. The safety parameters are not allowed to deviate or to exceed, because that is where the safety is there, factor of safety, safety margin. And all those safety requirements have to be properly put into the system. Could be in a safety instrumental system, or it could be our own technical systems. But this will, if the proper implementation of safety management system in the workplace, then definitely you can prevent accidents, emergencies, and disasters. And if you see, basically, when we talk about planning, we need to evaluate the risk and hazards in respect of the workers, in respect of the community, and what type of response procedures which we need to take it up. And we have to evaluate the resources availability in
Hope you
terms
would
of
have
normal
time.
circumstances, as well as in terms of emergency. And then you can also think about improving the plans to facilitate the disaster and emergency planning, and mechanical integrity, structural integrity, periodical testing and examination, a review, everything is a must for a dynamic disaster management planning. And community involvement, in fact, very important. The National Policy on Safety, Health and Environment at Workplace clearly says the community should be involved for better safety and health and disaster management. We need to increase the expectations of the community, as well as we also increase our performance requirements. So a DMP comprises both on-site and off-site. It's the, in the generic perspective, you take care of if an emergency happens inside the factory and those consequences are restricted within to the boundary of the factory, or it crosses the boundary, as in case of off-site emergency. Both the aspects are taken into account when we talk about the disaster management plan. And the off-site emergency plan, I think many of you must be knowing, the MSC rules clearly talks. It is prepared by the district administration. It talks about the various activities of the district authorities. The management, the chemical industry management, is under obligation to provide all the data to the district administration to formulate a plan, and it also gives roles and responsibilities of the various regulatory and other authorities for a better emergency planning. When I talk about safety and disaster, I'm reminded of this cycle, industrial disaster management cycle. Prevention, preparedness, and response. And if you see, it's a safety continuum. The prevention part is more focuses on safety, preventing an accident, preventing a hazard, preventing a risk or incident, whatever you do. The prevention part focuses more on safety. Your preparedness and response talks about disaster management planning. But you see, prevention is a must, because if it is the very successful one. By preventing it, the release of a chemical or release of the energy can be stopped at the once. And the question of the response doesn't arise if your prevention is 100% perfect. Coming to the comparison, safety and industrial disaster, I believe safety failure is the starting point for the disasters. There may be a small corrosion, pipeline crack, there could be a vibration, there could be check, there could be a pressure increase, there could be a failure of a relief valve, so whatever it is. The safety failure, the engineering failure, technological failure is the starting point for the disasters. Please keep in mind, the safety failure can also happen because of the natural factors. A lightning can blast the system and making a safety to fail, or a flood can come and then flood can submerge the equipment, allowing a safety system to fail, or even terrorism or your own high wind speed can make a safety system to fail. Having a safety management system, robust safety management system, is the foundation for the disaster management. Have a comprehensive, robust safety management system, because when you are able to manage the system by having a system approach when it comes to safety, the same system can be extended to disaster management. And the safety management people, fire safety management people, occupational health, emergency team members, everyone who works on safety can also play a pivotal role in disaster management in chemical industries. And the underlying meaning is, like, safety and health is the integral part of every operation activity, manufacturing activity, maintenance activity in a factory. The safety and disaster management should be an integral part of any industry. It should not be a compulsion that some legislative requirement is talking about it, some authorities are demanding it, or some agencies asking for it. It should be an integral component, because disaster management is very important, because it is the one which takes care of business continuity plan, business interruption, and sustainability of the business. I think with this, I'll close my presentation. Once again, I thank the organizers for giving an opportunity to share my thoughts with you. Thank you very much.
Well, thank you very much, sir. It was very interesting and very informative deliberation. And now we have some questions which are very interesting, and I'm sure you would like to address them. So what I understand is Mr. Datta has left. So with your kind permission, I will mix and match and try putting those questions to you, if it is okay. So
Yeah, please.
yeah, great. So we have Mr. Babu Bose with us. he appreciates, many of the things which have been discussed. But his very particular question is there any mandatory qualification, training, and experience for handling oil and mining or gas pipelines? So how can we reduce risk if that could be taken care of? And also he is interested to know how come the asset integrity is protected and win the public confidence. Over to you, please.
No, is it to me or Mr. Datta?
Mr. Datta has actually left, so I'm just taking liberty to put it to you. If you
Can you
would like,
again repeat the question if you don't mind?
yeah. So basically, he is interested in knowing, is there any mandatory qualification and training and experience for handling gas pipelines in country? And if that is so how it is being entertained. And second thing is, he is also interested to know about asset integrity, if that is being done and is being used for protection or winning the public confidence.
No, basically, I can talk about the pipelines within the factory premises. The pipeline layout, color, or integrity testing, pipeline testing are all mandatory requirements under the Factories Act and model factories rules or state factories rules. But of course, when it comes to cross-country pipelines, I think PNGRB Act and rules, they take care of it. And for conducting the other point, I think probably I think Datta should be able to answer in the second question. Yeah.
Okay, then we have Dr. V.S. Prakash with us. He is interested in know, is it possible to achieve zero level accidents? And but if not, so what kind of level of acceptance in terms of risk is there in industrial disasters?
Okay, see, first thing is we should understand the accident prevention or safety itself ideal philosophy. We want to prevent all the accidents or in all injuries happening in the workplaces. That is yeah, we expect an ideal condition. That's what probably when we talk about safety. When we talk about risk, we go to a kind of high risk, low risk, and medium risk. We are categorizing the hazard in terms of probability and consequence, and we try to say rank it high risk, low risk, and medium risk. But to ask me, no one would expect any accident to occur in workplace. In fact, if the accidents are happening on its own, there is no need for accident prevention in any industry. So nobody wants any accident. That is why now we talk about zero accident. In fact, the DGUV, we have DGFASLI, we have entered an MOU. They come out with the concept Vision Zero, a zero vision towards having zero accident, zero injuries, zero losses, and zero disturbances. You can take any zero like that. Ultimately, it is a philosophy. It can be achieved, but of course, to achieve it, then you need to devise so many things. It doesn't happen just by simply saying it or talking about it. It needs resources, it needs facilities, it needs various other instruments to be put in place to achieve that objective. So as a safety professional, I believe that it is achievable.
Great.
It
Then
is not
we
a
have,
kind of hypothetical condition. It is practical and realistic. Only thing is we need to work towards it.
okay. Then we do have appreciations from many participants. Colonel Sanjay Srivastava specifically appreciates this. While appreciating your lecture, he's asking, there is a custom of audit, like fire audit, safety audit, these
I
kinds
read
of
the
things.
question. It was
Please.
chat. The point is you can do disaster audit. It is not, it's nothing like impossible. Probably somebody should do it. Like I do an hygiene audit. Probably, DGFASLI, we are doing hygiene audits. Specifically talking, looking the hygiene aspect. We are doing audit for health, occupational health. We are doing audit for vibration. Or you are going to do audit for mechanical handling, metal handling. So there can be audit for disaster also. And if you talk about audit on disaster, to my knowledge, it is audit on safety. Probably you will come to the other phase preparedness, response, everything will come. Whereas when you talk about safety audit, then also we have a separate column. You go to IS 14489, 1998. Clearly, we have a specific element on emergency planning, which talks about your response procedures, team building, everything is there. Yes, you can do, because ultimately you need to develop a checklist and you should verify and you can do an audit and you can give your recommendation so that the industry can find out whether they are adequately doing the necessary things for the proper disaster management planning in their workplace. Yeah.
Great. Then we have a very young participant with us, Mr. Aniket. He says that, Ankit, sorry, he says that, many a times in industries, you have people from engineering background who take care of these kind of things. How about looking in a very holistic approach and appointing people who are actually trained in disaster and which can compensate much more and better things? How do you think about it?
No, the question is little complex because, see, when we talk about safety, I don't agree. Safety, we are also having engineers, we are also having science background people, physics and chemistry background peoples. Our students who complete diploma, they are from degree background with BSc physics and chemistry also. So I don't agree to the concept that only engineers are handling the safety. Again, it is, has been made under Section 40B of the Factories Act with a specific purpose, because they need to manage the safety organization in an industry. And based on the requirement, that qualification has been framed under the law. And as I told you, safety people, personal safety officers, safety personnel can be trained on disaster. And the people trained on disaster can work on safety. The question comes, only qualified safety people, then the difference comes. Otherwise, there is no bar for anyone to do anything. Ultimately, you need to have the knowledge, competency, skills, and the management should accept it. Only when you talk about some regulatory requirement, then those things come into.
Probably his question comes now, many of the institutes, universities, including ours and tests, we are having a special cadre of people who are trained in disaster management. So
I do agree.
Yeah.
And another important point is, in the factories, the disaster management, there is only one section, Section 41B4 of the Factories Act. It talks about hazardous industries listed in the first schedule of the Act to have on-site emergency plan and implement disaster control measures. Okay, we have not come to the level of putting a separate department with a certain qualification to manage a disaster. You must think they, as you are rightly said, the act came in 1881 in India first. This is the 6th Act, 1948 Act, which was amended in 1987. Then only the safety officer, everything has come into existence. Then in 85, late 80s, we brought factory medical officer. Presently, we are thinking about industrial hygienist. A day will come when we should think about the disaster management people also should be part of the organization.
Okay, great. So nice of you. There are so many good questions and all. Participants are quite active, but because of the paucity of time, I would like to go to Dr. Rakesh Dubeji to take it forward. And it was wonderful listening to you, sir, and even interacting with you while having these questions. So nice of you. Over to you, Dr. Dube, please.
Thank you. Thank you.
Good evening to all of you. Now we are on the concluding part of this our 6-day training program or the webinar. Today, Dr. Elangovan came, Director General DGFASLI. So, Dr. Elangovan ji, thanks for your nice acceptance and making presentation to our audiences and viewers about your thoughts and answering to the questions which are very relevant in the backdrop of this event for which it was organized. So thanks, Dr. Elangovan, and we hope that you will continue and you will patron such events because you are sitting at such positions that your presence makes a lot of sense to the audiences. So we hope that you will continue to keep such views for such events. Dr. Elangovan, thanks for accepting this and coming here. I would like to thank Dr. Hira Datta. He's well known in the oil and gas sector. Everyone knows him. And he was earlier executive director, and then he worked in the oil and gas sector for long. And the way he made presentation and the way he has highlighted the key elements for making safety as a important goal for the overall industrial setup. It's really wonderful, and we hope that Mr. Datta will continue such type of support for such events. So thank you, Mr. Datta ji, for making a nice presentation, holistic view. Professor Joshi, yes. No doubt you have nicely coordinated this program, and I am observing that from JNU you are the only professor who was throughout the session. So thanks for your sincerity and thanks for your this keenness for this program, and we hope that you will continue to support such type of activities. Since we are going to conclude this session, so I would like to brief our 5 days activities, because DGFASLI is sitting here and he should know that what we did in the last 5 days. It's very important. Uh, Dr. Elangovan ji, first day we invited Professor Delanti Amartunga. She is the head of disaster, Global Disaster Resilience Center of UK at Huddersfield University. And we requested him to say about Sendai framework challenges and the way ahead. And basically, the Sendai framework is the cause for holding this program, because 13th was the day of International Day for Disaster Reduction. So he nicely made all aspects of the Sendai framework, covering 7 targets and 4 priorities actions. And this session was viewed widely even in UK, and it was accepted, and we got number of appreciation for this session on the 13th day. Second day was very important, and as a DGFASLI, you would like to appreciate, and you will appreciate that on the second day we invited this power sector, that what are the challenges, how we have to go way ahead in this direction. So we invited Mr. A.K. Pandey. He is the executive director of he is the regional executive director of West 1 of NTPC. He made wonderful case studies, and he also highlighted the bottlenecks, and he also suggested the way ahead. Wonderful program he made it, and Professor Sunita Reddy was the moderator. She had nicely moderated this program, and audiences were quite happy, and they are also willing to work for the power sector in safety and environment related field. Third day was very important, where we requested Mr. N. Bose Babu. He is a CEO of GITL. GITL basically one subsidiary of GSPL, headquartered at Gujarat, Gandhinagar. Uh, and we requested him to highlight the issues related to six and disaster for the city gas distribution system, because nowadays number of cities are likely to be covered under CGDs. I understand that almost more than 400 cities have been covered. So he made very good challenges, and today he also raised certain important questions about the qualification, about the operators. So Dr. Elangovan, this is one point and curiosity for me as well. Can we think for developing certain course module, some maybe certificate course 3 months or 6 months for the operators? Because you know CGTs are coming in 400 plus city, and each city will have number of stations, this fueling station for the our vehicle, for the home. So and I will agree with him, and I am also having some exposure about the CGT. I understand that operators are not available, qualified operators are not available. So if you agree, I will speak to you separately, because you are sitting at such important position, if we can work jointly, keeping and Bose Babu also in our loop for the need which is today's time under the skill development program, and we can have certain skill certification course under your patronage, so that our young generation can get employment, because people are getting, number of persons are getting in engineering and doctors, but again the question is the job. So this sector needs not the high profile person, the middle class or this intermediate or high school candidates can go ahead. So I will, this point was raised Mr. N. Bose Babu, and today he also raised the same question. I will definitely speak to you, and I hope that you will extend the same support what you extended this our 6 days.
Yeah, it is there.
Yeah, please. Yes, yes. Thanks, Dr. Elangovan. And this program was coordinated nicely by Professor Rajini Srivastava. I would like to highlight that in all the 6 days, we invited academic persons, so that there should be some blending of professionalism with the academy, because ultimately, if we have good academic institution, they will develop good person, good professional, which will ultimately support our system. So Rajini Srivastava nicely coordinated from Allahabad University. Fourth day was from was given by Dr. S.P. Garg. He is an advisor to GAIL. He spoke about the cross-country pipeline, and I understand the lot of issues what Mr. Hirak Datta said today. He answered what questions were there on that day when Dr. S.P. Garg made presentation about the cross-country pipeline, and he nicely presented and addressed the questions which were in the session of the S.P. Garg. And this session was coordinated by Mr. Professor Abhijit Dwivedi. He is also an assistant professor of JNU. Then fifth day, means yesterday, we touched this lightning casualty in the monsoon. This is very important. So Professor, or you can say Colonel Sanjay Srivastava, who is a chairperson of CropC, made a wonderful presentation about the casualty of the lightning, and he also tried to make certain loop with the industrial sector, that how damages are being happening in the industrial sector due to lightning. And there is also a lot of scope to work. I have certain clues. Since time is less, so I will definitely speak with you separately on this aspect. And I understand that under your leadership, this lightning can also be addressed for the safety of the plant and also for the safety of our society. And this is the last, and you chaired this session, or I should say, the whole program is taking concluding under your chairmanship. So Dr. Elangovan, thanks for you for coming here, and you nicely highlighted all aspects about the disaster safety and about the provisions, what's going on, and the way you discuss. And I understand you are working in number of investigating committee of the accident. And separately we can discuss that how we can develop on this process. And in my opinion, there is one need we have to go ahead with your support under your leadership, that we should need to develop certain accident protocols. They are missing, and if we go for the accident protocols, they should have certain legal teeth, so that it can be more effective, and it can also be monitored by respective agencies. And lastly, I would like to thanks to my partners. Without that, it could not have been possible. So first of all audiences, and we appreciate that about 500 participants in these 6 days participated, and I understand this was a good number across the country. So first of all, I would like to thank all audiences, all viewers for their questions and for their interest they express in this 6 days event. I hope that these audiences will continue to support for such type of events. Our partners are very important. So first of all, Colonel Sanjay Srivastava, he's a chairperson of the Prof. He was supportive in organizing and supporting this event. GNU professor, especially PK Joshi ji, who is the chairperson of Center for Disaster Research in GNU. He nicely helped, and he was, as I told you in the beginning, that he was in the whole session, and he deputed his faculty to coordinate one faculty in one session. So Professor Joshi and JNU University for again support. Our third partner is Health Crum, those who are managing this, virtual platform dialogue with persons like you, even our delegates, our speakers, making comfort to them so that they can reach virtual platform. My thanks will not be completed if I will not express the thanks to Dr. Mr. Chaudhary, DC Chaudhary. You might be knowing, or you must be knowing, that he is earlier ex-director of Industrial Safety. He is presently one of the directors of this EIDMP Academy, and he was instrumental in doing this program. Rather, I should say he was one of the architecture of making this plan. So I would lastly thanks to Mr. Chaudhary, who was ex-director of Industrial Health and Safety. With all due permission, if our chairperson wants to make any comment, we will welcome, and after his comment, we would like to conclude the session. So, Sir Dr. Elangovan ji, I would like to invite you to make a comment as a chairperson of the today's as well as the whole sessions program. Dr. Elangovan, over to you.
I'd like to congratulate all the team. Of course, I couldn't attend all your earlier session, but from your summary, I could find out that there had been really a meaningful discussion. As you rightly said, disaster management cannot happen without involving the workers in the industry. They have to be trained, they have to be properly qualified, they have to be give important knowledge in disaster management. In one of the cases, the people even doesn't know that they should operate a manual call point or a fire alarm or an emergency alarm. Even though the emergency plan is there, systems are there, people are given responsibility, but in a real emergency, they didn't do it. In fact, one of the issues is they don't know what to do. Probably they have not even know how a manual call point will look like, or where the emergency siren is located. See, basically the emergency management, the disaster management cannot be successful without involving the workers of the industry in particular. Of course, supervisors, managers, and top management, everybody is required. In that perspective, whatever you are proposing, that you have to do something probably to improve their knowledge and skills in a disaster, the most welcome. And it's a good initiative. I would say all the sessions, I'm seeing the feedback also, good sessions spanning for a week, and then many top luminaries talking on the subject. And of course, I know you have a very good experience, and being a good friend, you have a very long experience in the disaster management. And I could see today Chaudhary Sahab after a long time. In fact, I met him at least 4-5 years back in his office. So it basically bringing like-minded people on a common platform so that things can be benefited. And society is given some real inputs for betterment of the disaster management. I think that's my view and inputs to you. Again, once again, I thank you for inviting and to be part of this August program. Thank you.
Thank you, sir. Thank you. चौधरी जी, आप कुछ कहना चाहेंगे? चौधरी जी, DC Chaudhary. Okay, probably he left. Professor Joshi, I think, hello.
Yes, sir.
Professor Joshi ji, I think that You nicely coordinated these 6 days, and you have credit. So I would like to request you to conclude and declare the session should be closed. Please, over to you, Professor Joshi.
Many thanks for giving this opportunity. In fact, I was privileged to attend all the lectures, and many of our students also attended these randomly. And those who couldn't attend it, students from my university or other universities, they have actually missed something very meaningful, which was very much needed. As I said in my opening remarks, it was a wonderful blend of envisaging a wonderful blend between industry and academics, which most of the time governance and policy making needs or looks for. So I must congratulate to you, to your entire team, including CropC, for such a wonderful initiative, such a meaningful dent in the entire spectra of knowledge which is being synthesized or being generated in the field of disaster management. And I must confess, each of the speaker was fabulous. It's just not today's two speakers, which I got privileged to coordinate, but the earlier speakers also, they actually brought very insightful things, which are equally important for academicians like me and professionals like you or Colonel Srivastavaji and likewise many other participants. I look forward that certainly you will come with much more innovative ways of bringing people together, discussing and sharing their knowledges and experiences. So with these brief words, I would like to thank you for giving this opportunity to express today and attend all these 5 days. So nice of you, and I wish in time to come, we'll get similar kind of sessions or events very soon. Thank you one and all. So as Dr. Rakesh Dubeji said, with the kind permission of the chair of the session today and all the participants, let us call this wonderful event closed for today. But soon, I'm sure, we'll be coming with much more insightful, similar kind of discussions. Thanks once and again. Thank you very much.
Thank you.
Thank you.